Professor Nace. This is TeamPSX. On this team is Mike Rosen, Arnav Malik, and me, Anita Zhang. And this is our project proposal. Our project is the recreation of the original PlayStation. It was Sony's first PlayStation console, released in the mid-1990s. It is a 32-bit console that features support for 2 controllers, each with at least 17 inputs, a standard CD-ROM reader, EEPROM memory cards, and composite video-audio output. Our goal is to recreate all the major components of the PlayStation on an FPGA. These components will be detailed later, but it includes the CPU, GPU, SPU, and more. We will be interfacing with the original PlayStation controllers. Due to board choices, we will have to output both sound and audio through HDMI. We're aiming to play games from original CD-ROMs, though it is a possibility that we will move to a different storage device depending on availability of documentation and time. Optional components, such as memory card support, are left for last as additional goals once everything is working.
Research for the PSX started off with a bit of a struggle. Looking at the time period of the original PlayStation, we are approaching the point in time where documentation is not as readily available, and companies are steering towards a more closed environment. However, once we started to hone in on the right search parameters, we found several resources with abundant information to get us started. One such resource was psxdev.net. This is a developer network and site for the PSX. Here we found all the tools for development. A plus point of the time period is that developers were almost required to be familiar with the hardware they were working with to get things done with their limited resources. So, this means that the developer site has lots of information ranging from service manuals with entire device schematics and wire diagrams to information on registers and instructions for individual components in the design. In addition to the developer resources, there are several documents put together by random people. They detail things such as the modifications made to the CPU by Sony, like additional instructions, etc. Another source of information we will use is from the emulator scene, where there are a few open source projects that can provide further insight into the hardware of the PSX. We chose to use the Vertex 7 for a few reasons. The first reason is size. We were slightly concerned that we may need some of the additional space provided by the Vertex 7 to avoid running into the size problems that some other groups have faced in the past. Another reason we chose the Vertex 7 was to try out Vivado with the promise of better performance and usability over ISE. This segues into our choice of language. We targeted Vivado particularly because it has support for System Verilog, and since we all have experience with the language, it was the obvious choice. Another crucial factor in our decision is that we faced driver issues and some frustrations using ISE and the Vertex 5 board. We snagged the TA Vertex 7 a few days ago in lab and had much more success getting the tools working. So naturally, since there was still a Vertex 7 up for grabs, we took it.
We have been able to break down the PSX into several core components: the CPU, GPU, MDEC, SPU, disk reader, memory plus DMA controllers, screen interface, and memory card/controller interface. The CPU will be discussed shortly. Main memory for the PSX consists of 2 MB of DRAM. The GPU handles all 2D rendering and graphics calculations for the system, with an adjustable frame buffer located in a 1 MB VRAM chip. The GPU has 2 dedicated DMA channels to allow for quicker access to main memory. The MDEC is responsible for decompressing audio and video from the format stored in the CD-ROM. This unit is part of the main CPU chip in the original PSX hardware, but unlike the other components on the CPU chip, is located on the main system bus rather than as a coprocessor. This unit also has 2 DMA channels, one for reading compressed data and another for writing uncompressed data to be retrieved by the GPU. The SPU is responsible for processing sound data, containing 24 hardware voices and a 512 kilobyte sound buffer. The PSX games are stored on CD-ROMs. We plan to interface with a disk reader allowing us to read from the original PSX CDs. While the original PSX output composite video and audio, we will output video and audio via HDMI due to the outputs available on the Vertex 7 board. However, we plan to use the original PSX controllers as user input, as well as original memory cards for saving game data if time allows. Many of these components will have to be implemented by our team. The CPU on the PSX is a 32-bit R3000A MIPS processor implementing the MIPS-1 ISA, clocked at 33.8 MHz. We have found an open-source MIPS-1 32-bit core on opencores.org, so we plan to use this as the starting point for implementing the CPU and its coprocessors. The two coprocessors, COP0 and the GTE, will likely have to be implemented by us. COP0, or Coprocessor 0, handles exceptions and some memory functions. As the GPU solely processes 2D graphics, the GTE is responsible for processing 3D graphical information into 2D graphical data using a variety of complex math and matrix functions. This processor's functions and interface with the main CPU as coprocessor 2 are fairly well documented, so implementing it should not be too difficult.
Thanks for your attention. The remainder of this video is PlayStation gameplay footage, so feel free to stop at any time.